This video is about inductor. Inductor is a passive component which stores energy in the form of magnetic field. It is a wire or a coil. The equation for the inductor can be written as V equal to L into di by dt, where V is a magnetic field across the inductor and L is the inductance of an inductor in henries, and di by dt is rate of current change at that instance. I am going to use water analogy to understand more about inductors. We will associate the inductor in terms of the analogy with a water wheel which sits in the flow of water. I mean here. Let's assume this is a flow of water and this is a water wheel. Initially, as the wheel has mass, it does not turn. However, the force slowly begins to cause the wheel to turn, and soon the wheel turning at the rate equal to the flow of the water here. This is how an inductor works. Initially, it starts to resist current when we applied the voltage. Here it is a water flow, is a water force, and eventually it allows the current to pass through it. Even after stop applying the voltage, there will be a current flow through the inductor. So, if I apply a voltage in the inductor, it begins to resist the current flow, and eventually there will be a current flow and continues to carry current for some times even after I turned off the voltage source. As the motor takes some time to comes to the rest, even though there is no force acting on the motor. In inductor, there are two important properties. Here the current lags the voltage by 90 degrees and it does not consume power. Here is the proof. Let's say the equation for the inductor is V equal to L di by dt. Let's take current is equal to A sin omega t. I want to derive the voltage equation, so I'm just substituting everything in that equation, substituting the value of I will get the voltage is equal to this L into omega here is angular frequency, A cos omega t. What I want to do is I want to calculate the power of the inductor. So the power of the inductor will be P RMS. I'm calculating the AC. So 1 over T integral over a time V into I dt. So I'm going to integrate with respect to time. So I'm going to substitute the value here, and I'm changing the interval from 0 to 2 pi. So if I manipulate those two things, I will rearrange the equation like this. See, here is a 2 omega t. If I actually integrate it, I will get something like a sine wave. If I integrate the sine 2 theta, I will get minus cos 2 theta by 2. So anyway, is cos 2 theta. So the cos 2 theta will become 0. So the whole equation, if I multiply with anything, the whole equation will become 0. So the P RMS is equal to 0. So I can say the inductor it does not consume power.